Thank you so much for joining this lesson. We're going to discuss area approximation by both the mid-ordinate rule, also the trapezium rule. The diagram below shows a sketch of the curve y equals to 2x squared plus 5. So we can see the sketch of the curve. Then we are told that in part A, using the trapezium rule with 6 strips, estimate the area bounded by the curve. The lines x equals to negative 2.5 and x equals to 3.5, and the line y equals to 3. Line y equals to 3. So look at this now. We are first of all going to establish the intervals. We establish the intervals that we're going to use in this particular case. So the intervals that we shall be using in this case are going to be, the intervals that we shall use are going to be, we want to ensure that we come up with 6 strips. So we check the range of values from -2 all the way to 3.5. So you check the interval there. 3.5 minus 2.5 negative, I'm getting exactly 6. So for us to get 6 strips, then we use intervals of 1 unit. 1 unit, because they are already 6 intervals. So we start with the values of x, then corresponding height of the curve. Corresponding height of the curve. Let me check. Need 6 of them. Right. The first one is 2.5 negative. When we substitute 2.5 in the function y equals to 2x squared plus 5, we're going to get, let me check, we give you that, 2 into negative 2.5 squared plus 5. This gives me 17.5. Then we go to the next. After an interval of 1, negative 2.5, we add 1, we're going to negative 1.5. So 2 into negative 1.5, we square, then plus 5. This gives us 9.5. Then from here, we go to negative 0.5. Negative 0.5. You see, with negative 0.5, now we need 2 into 0.5, we square, then plus 5. This gives us 5.5, right? 5.5 that way. Then the other one will be now 0.5. After one complete unit, we go to 0.5. When we substitute 0.5, we'll be having 2 into 0.5. That one is squared, then plus 5. We get still 5.5. Then from here, we go to 1.5, 2.5, then finally 3.5. Let's check at 1.5. 2 into 1.5, we square, plus 5, giving us 9.5. Then 2 into 2.5 squared plus 5, we get 17.5. And finally, 2 into 3.5 squared, and we add 5. This is 29.5. So the area we will get now, according to the trapezium rule, will be the area between the curve and the x-axis. Let's take note of that. The curve and the x-axis. Therefore, area estimated shall be given by f times h, which is now the interval which has been used. Then we have the first and the last y added, plus 2 multiplied by the other values of y now in between all the y's, all the way to the y just before the last one. So that is the formula for estimating area. Half times the interval, which is 1, into the first y, 17.5, the last y, 29.5. Those ones are added. Then 2 multiplies all the other y's, 9.5 plus 5.5 plus 5.5 again, plus 9.5 plus 17.5. So we are talking of half times the interval, the first and the last y added, 2 multiplied by all the other y's. That's how we get the area using the trapezium rule. This is 0.5. Then here we are having 29.5 and 17.5, giving us 47. Then we add 2 into 9, 2 into 9.5 plus 5.5 plus 5.5 plus 9.5 and 17.5. So this gives us 95. So the area is going to be, when we add 47 to this, then we multiply by half, you're getting 71 units. Now, 71 units is the area between the curve and the x-axis and the lines. X equals to negative 2.5 and x equals to 3.5. Mark the word x-axis, but now we need the area between the same intervals and y equals to 3, this one. So now we say that we have gotten the area from this curve all the way to x-axis. But now the area we need is this one, between the curve and y equals to 3. So we have to substitute, we have to subtract the unshaded area here. We subtract the unshaded here because we've gotten already all this area. So we've gotten all this area. We've gotten all this. I'm sorry, let me adjust my screen. We've gotten all this area, or this one. So we have to subtract this part now, whereby it is 6 units along the x and 3 units upwards. So we subtract 6 by 3. So we're supposed to subtract now 6 times 3, which is 18. 71 minus 18. This gives us 53. So area is going to be 53 square units. Yeah, 53 square units. So that's how the area is estimated. We are also told to calculate the difference in area estimated in A above if the mid-ordinate rule with 6 strips is used instead of the trapezium rule. So we're going now to check the same area using the mid-ordinate rule. As we adjust to the mid-ordinate rule, let me bring to your attention some of our programs here. Every weekend, we mentor the candidates. Saturday, we have the Kcse candidates. Sundays, we have the Kcse candidates. Our consultation line is already attached on the wall. You can consult using our number here to know more about our programs. This is happening through Google Meet, whereby there is a lot of interaction. You can ask questions, you can answer questions, you can seek clarity and all that. Then we have the holiday program here, whereby we are calling it the One Term Ahead program from the 10th of November to 12th December, covering 2026 Term 1 work, whereby we target the junior school and also the senior school, still happening through Google Meet. We shall cover the Term 1 work. So please feel free to enroll. Feel free to consult about the same. Our number is open 24/7 for calls and WhatsApp. So thank you so much for being part of this group. Now we continue with the question whereby we are adjusting the method now from a mid-ordinate rule to, from the trapezium rule to the mid-ordinate rule. Now, when we are having all the strips, it's very easy now to get the middle heights. So we want to estimate the area using the middle heights only. Yeah, using the middle heights. The middle heights instead of the heights that shield each strip. Let me show you the difference between mid-ordinate and trapezium. A minute. Once I'm done the table, I'll take you to the difference between mid-ordinate and the trapezium rule. So we'll have X values there, the Y values there. What we are having here is the strips at the borders, these points, like at 1.5, then at 0.5 negative, then we go to 0.5, 1.5, 2.5, 3.5. So these are what we call the strips. Now we are focused on the middle heights of every strip. If it's between negative 2.5 and negative 1.5, now we focus on the height at the middle. This is the strip. Now we focus on the height at the middle. So the average of negative 2.5 and negative 1.5, the average is negative 2. So the height at x equals to negative 2. That's what we need. So those are the values of x we need. Again, this is negative 0.5. This is negative 1.5, the middle height. So the middle height will be the height when x equals to the average of negative 1.5 and negative 2.5, which is negative 1. So the height at x equals to negative 1. We go to the next. From 0.5 negative to positive 0.5, the average is exactly 0. So the height at x equals to 0. The next shall be from 0.5 to 1.5, the height at the middle, the height of the strip, which is at the middle. So 0.5 and 1.5, we'll get exactly 1. So the height at x equals to 1. The next is, we consider 1.5 and 2.5, whereby at the mid, we need the height at that point, where x equals to exactly 2. And finally, from 2.5 to 3.5, the height at the middle, that is the height when x is exactly 3. Like that. So now we can get the values of x, or rather the heights at the mid. The heights at the mid. So we need 2 into negative 2.5 squared plus 5, giving us exactly 13. 12, yeah, 13. Then 2 into negative 1 squared plus 5, giving us exactly 7. This one will give us 5 because 2 into 0 becomes 0 plus 5. 2 into 1 squared, we get 7 there. Then 2 into 2 squared plus 5, this will give us 13. And finally, 2 into 3 squared plus 5, this gives 23. So we have all the heights at the mid of every strip. The heights at the mid of every strip. So now this is what we are going to use. Area using the mid-ordinate rule is estimated by height, which is the interval on the x-axis, into all the values of y added. All the values of y added, all of them. So now we'll talk about the interval, which is 1, 13, plus 7, plus 5, plus 7, plus 13 again, plus 23. Yeah, so this is going to be 20 plus 20, 40, 45, 45 plus 23. This gives us 68. Yeah, 68 like that. Square units. Yeah, 68 square units. Then with that, remember we have estimated the area now between the curve and the x-axis. Yet, we're supposed to find the area between the curve and line y equals to 0 within the lines x equals to negative 2.5 and positive 3.5. So again, we are supposed to subtract the area, which is unshaded at this point. So this unshaded area, because it is on along the line y equals to 3, then it has 3 units upwards, and along the x-axis, we have 6 units. So we are supposed to subtract 18 from this. And this gives us exactly 50 square units. Now, what we want to find, finally, going back to the question, we are calculating the difference in area when mid-ordinate rule is used, and also when the trapezium rule is used. So the difference in area shall be, in part A, we found 53, and now we are finding 50. We write it well. We are now finding 50. Therefore, this shall be 3 square units. That's the difference in area using the 2 different methods of area estimation. How have you been charging airtime in your phone? Welcome to our model here. Just go to your M-Pesa, Lipa na M-Pesa. Then the pay bill number is 737356. Account number is the phone number that you're purchasing the airtime for. Then after that, you enter the amount that you'd like to spend. Then you proceed to complete the transaction, and your airtime shall be reflected instantly.